Hey everyone, it's Miss Watkins. I'm going to try to teach you about some of the things from our website on chemistry today. So I'm going to go over the mole dollar, I'm going to go over the molar conversions, how to do formula mass, how to do molecular mass, how to do percent composition. So there's quite a bit that we'll cover, so I just hope that you're going to have your notebook with you so that you can get these things. You'll need your folder with the worksheets that I've given you. Those of you that were not at school, it has been mailed to you. Hopefully you'll get it in the next few days and can come back to this video and get what you need. This is the mole dollar that you need. We're going to add something to the back of that. So I've got a dry erase board to show you what you put on the back. This can be found on my mole PowerPoint, which is on Google Classroom, and on my teacher website. Alright, the mole is very, very important because it allows us to convert from what we cannot see to what we can see. It's very similar to an ATM machine. With an ATM machine, you know that there's a balance. You can decide to extract money from that balance and get the money in hand, which is tangible. But you can't actually see the money. It's as a text or a number given to you saying that you have $100 in the bank and you want to take 20 out. So you press a couple of keys. So the ATM acts as the mole. So what we're going to do is we're going to learn how to go from something that's big that we can't see to something that's much smaller that we can see. So in the top left, you're going to put ions, formula units, atoms, and molecules. And to get from these really, really big things to the mole in the middle, we have to divide by Avogadro's number. Now, Avogadro's number is a very fixed number, 6.02 times 10 to the 23rd power. So it will take you from something really, really big to something smaller, the mole. Now, if I have the mole in the middle, I can choose to go to those other units by now multiplying by Avogadro's number. Now, it's a capital N with a capital A subscript, so it's not to be confused with N little a, which is sodium, which we learned on the periodic table. Okay? Now I want to get to something that I can see, I can feel, it's there, it's present. That's where mass comes in. Mass is in the bottom left and it's in the bottom right. So to get from the mole to mass, or from mass to mole, I have to use a molar mass. I have to use my periodic table to use those atomic mass numbers, add them up to get a value. So to go from mass to moles, I divide by the molar mass. And to go from mole to mass, I multiply by molar mass. Now, what is a molar mass? Well, that's where the formula mass and molecular mass worksheet come in. That is this document here. Okay, this was in your worksheets packet. So I'm going to help you with the first one. Formula mass is for ionic compounds. And on the back is for molecular mass, which is for covalent compounds. Alright, so with this formula mass problem, I see N, H, S, and O. These are the elements that are involved in the reaction, the compound. So I take them apart, each one, and then I'm going to add the atomic mass, not the number, from the periodic table. And I'm going to multiply it by the number of atoms present in my formula. I'm going to the tens place. Okay, so I have 14.0 times 2, because of that 2 on the outside of the parentheses. I have 1.0 times 8, because 2 times 4 is 8. I have 32.1 times 1, because there's only one sulfur. And I've got 16.0 times 4, because there's 4. So I'm going to multiply. So now I have individual totals, and I'm going to add that up to get my combined total. Now, for now, we're just going to put the total 132.1 U for units. So you add up each one of these and get the total of 132.1. So that is the formula mass for ammonium sulfate, an ionic compound. Now, we're going to do the same math for molecular mass, which is for a covalent compound. So I've got carbon, hydrogen, and oxygen. So there's 2 carbons, 2 hydrogens, 2 oxygens. I'm going to get those masses again. I'm going to get a total. Going to the tens place. Now, I know some of you are saying, well, okay, Miss Watkins, why do we keep going to the tens place? Well, we keep going to the tens place because of sig figs. So remember, when you add, the final actions addition is based on your decimal place. So if you're consistent where you're going each time, your final answer will have less error and be to the same number of decimal places. So that's how you do that. I'm going to stop this video, post it, and then come back and do another video in just a moment.